Hi all. So today let us see what exactly the Kubernetes and why do we require Kubernetes, how it was before Kubernetes, and how it is going to work, comparison of older version as of now today's gen, how it is going, how the deployment is all going, and how it is being handled. So based on the traffic, everything we're going to see and understand in this session. So in this session's agenda would be, that is the pre-Kubernetes era, that is before Kubernetes, how they were used to deploy the applications, and our focus point, that is spotlight. So what is Kubernetes and the architecture, manifest file, everything we'll go in, see and try to understand what are all those things. Okay, so let us understand what is pre-Kubernetes era. So that is before Kubernetes, how the application were used to deployed and how they used to maintain. So before Kubernetes or the Dockers, they used to deploy the applications or the web servers or the everything softwares in the physical form of servers only. So that is what they are saying, that applications were deployed directly onto the physical server. So each server is often run on multiple applications. So for example, one server is running on some Apache and that supports only the Apache so and so versions, for example 1.2.0 versions, and the another dependencies wants to work on different version which is not supported for the older versions which supports latest version. So this was all the challenges being issued while deploying on the physical servers and used to manage manually everything. So leading to conflicts. So that is what I just explained. Right. So there on the what are the challenges we were used to have during the physical servers. Right. Insufficient use of server resources. For example, what exactly they are telling is, assume that we have three different servers and all are having three different microservices which are up and running, and for login or the sign up microservice we deployed on server A, and catalog of the that is products are deployed in physical server B, and the C for final cart and the checkout, that is payment, that is maintained by physical server C. Okay, so in physical server A, so that just to understand that we have a memory in common for all three servers, having 32 GB of RAM and so on. That is 1 terabytes of ROM, right? So for signing or sign up that microservice, that's requires only max to max of 8 GB of RAM. So rest we end up with, that is almost 24 GB of RAM left underutilized, and also the microservice or the file, what are the resource that was coded to follow the sign up or the sign in procedure, so that occupies only the max to max of 1 GB. Just assumption we are taking here. So the rest, so whatever the 900 and odd GBs were underutilized, right? So for that purpose, that was the challenge. So simply they used to invest on the hardware components, so in priority. So in future, if they want to scale up, if required based on the traffic or some sales was happening, so to do all those things, again they have to invest, right? So initially they have pull up everything, so whatever they required for intermediate level of traffic, so based on the analysis of previous few years, right? So on that case, the physical servers could create of the seasons or the sales of insufficient use of server resources, right? And scaling required manually provisioning new physical servers. If so, even beyond that initial infrastructure configuration, even if they want to scale up their servers, they need to configure everything manually. They need to give connections and they need to configure, they need to test everything they need to do. So the lot, it's quite more expensive. We require more man resources and the space, everything, right? So that was the major issues, and also there was no isolation between the application. So for example, that in one server I have a Windows, in another server if I want to put Linux and wants to link those two microservice, it was completely hell like things. So different configuration and linking them. So that was also an issue in that is what they are mentioned, that is no isolation between the applications, that they don't have anything that wants to run independently before without depending on the one microservice or the dependencies of the libraries or the version what they are. So that was also the problem. So to work on those things, they have come up with the concept of virtual machines. So what exactly the virtual machines? So virtualizations allow multiple virtual machines to run on a single physical server. So here we have a physical server, right? So if I want to deploy through that is three different microservices, I used to take up three different physical servers. But whereas here, when it comes to here, they take high configuration physical server initially. In that itself, they're going to virtualize or partitioning of the hardware things using the hypervisor. So hypervisor is an intermediate agent who takes case of dividing or allocating the CPU, RAM, ROM, everything. So based on the requirements, right? So and it could have its own independent operating system. It's not recommended to be have all the virtual machine should have the same as a host machine ones. That is, assume that I'm using the Windows 7 and there I have embedded the hypervisor using any some existing one, and I try to virtualize my hardware, right? So it's not recommended all the virtual machines should have a Windows 7. It can have Mac, it can have Ubuntu, it can have Linux, or it could have Windows 2, right? So that is what they are telling. So each with its own operating system and application stacks. Okay. So I'm going to explain with diagrammatically. So in virtual machines, what were they using? What were they were used to face challenges, right? So in VMs introduced overhead by running full operating system, reducing the efficiency use of hardware resources. So assume that so already the host is already running, that is Windows 7, and on top of that the hypervisor is taking care of all the virtual machines which are running different things. So here Windows 7 is not being used, right? So obviously they are read by running the full operating system. It's not actually recommended or required to run the full operating systems. Even when I'm using the Ubuntu, it's not required to run Windows. So it's actually running to provide service for VMs, right? So the reducing of efficiency there. Since the CPU as well as the memory being used by the host machine also, right? Or the host operating system. So we reduce the efficiency there. And managing VMs at scales were still complex, and scaling required managing more VMs manually. So for example, that initially I have launched three different VMs on top of my Windows 7 using the hypervisor. So in future, if I want to required or if I want to scale up the existing VMs, again manually I have to do that. So based on I have to go for hypervisor, and I have to request for this many resources I want, since I want to run more application even more smoothly like that. So even the configuration has to be managed and manually, and there might be a chance of crash during the upgradation of infrastructure. So it was quite complex, and during that process the application will be down, so till the infrastructure scaling up take place, right? So these were all the issues we were facing even in the VMs too. So to overcome all those things, they have come up with the concept of containers or containerizations. So in containerization, even they are doing manually here too, but with a different technology and the methods, I can say that. So manual container deployment, so how exactly it was going. So with the rise of Docker and the Linux containers, application could be packed into containers. So there, what we used to do in physical server, we take one single server and we install whatever the requirement we want to run that application, and we used to keep it. And when it comes to VMs, what we used to do, same thing, but with a virtual concept. But when it comes to containers, so assume that you have one container in that. So you want something to be cooked, right? So you want some flavored surprise to be cooked. So what do you used to do? So what are the requirements to get that flavored rice? We pack everything into that container and we start cooking, right? So same way here also in the manual container deployment. So what are the deployments, what are the applications we want, what are the servers we want to use, everything will be packed in that container and we going to deploy that manually, right? So could be packed into container. So however the deployment was still manual, typically on a single server or a small set of servers, right? Even though it is quite similar, but comparatively for maintaining all these things, we were used to make the packed one instead of maintaining manually and independently. Okay. So even here also we were used to face challenges, obviously. So what were the challenges? So in case of high traffic, uh, occasionally we would have a sales, right? The offers were given from the platform. On that case, obviously the number of people who looks for their requirement will be more compared to normal time. So if the traffic increases, developer has to manually start new container. So whatever the package container they own, again they have to create with the same configuration, same application, and again they have to deploy and they have to manage under load balancer to make available to the end users without any downtime, right? From there, we come up with discovery. That is, connecting to container require custom configuration like static IP or hard coded errors, as I just mentioned, right? So even after deploying the containers, even they need to map to the load balancers, or else they need to map that containers IP or the ID, so whatever they have, to the DNS, or else even if they launch or new containers, it won't get visible or the available to the end users. So even the service discovery has to be maintained manually, right? So how they are used to configuration management tool. So for that purpose, what they were using to maintain the application configuration, they were used to have Jeff, like these were all the tools, or the, yes, these are all the tools actually. So they used to achieve the application configuration, keeping up to date, so without any interruptions. They have come up with these concepts, that is Jeff, Wait, Ansible, sort stack. So these are a very few things. Okay. So these tools were used to automate the deployment of software and manage infrastructures through code. So to overcome all these manual steps, what they have come across is, or come up with the new technology, that is using these any one of the tool. What they use, they started writing the scripts or the playbook or the manifest file we called. So just keep those words in mind. We'll see what exactly all those in future slides. So these tools were used to automate the deployment of the softwares and manage infrastructures through code, right? So even in the manual container, they used to face problem. That is, these tools focus more on provisioning and configuration, not orchestrating containers at scales. That is, so whatever the configuration managing tool they were using, they are more focused on provisioning and configuration the infrastructure, but not the container at the scale. So what does it mean? Means whatever the base infrastructure, that is storage, RAM, CPUs, everything will taken care by those tools, right? So based on the requirement, but not on automating and deploying the containers. So that was the issue they were having in these tools. So there is no built-in capabilities for auto-scaling, load balancing, and self-healing that Kubernetes would provide later. So in container, in VMs, or in physical servers, we do not have the concepts of auto-scaling, load balancing, self-healing. So what is auto-scaling? So as I just mentioning from all previous slides that when the sales goes up, obviously the person one who comes and browse for the products or look for the products are gradually more to other days, right? So on that case, even if I am running my application only on one that server, I cannot able to give service properly to each and everyone. So there might be a delay or the latencies, or there might be some system crash, everything might happen. So for that purpose, we used to embed a new server manually by sharing the traffic or by analyzing the traffic. So that was not there in before Kubernetes era, and the load balancing too. So load balancings are integrated manually post deployment or post containerization, post VMs configuration, everything, right? So after doing those things, configuration on top of those VMs or the kind of Docker containers or the Linux container, we used to set up load balancer to control the traffic and to distribute the incoming traffic among the available servers, right? If I have 2 3 servers means, so based on analysis, it going to send and diverts the traffic into all 3 servers, so without stressing out the single server, right? And also the self healing. So the concept of self healing is something like assume that you have a one server, sorry, you are running with 3 server with having the same application running over there. Assume that the one server got crashed due to the voltage or due to the traffic management, so many kind. So it got crashed, right? So I are only left with 2 server, but I that is I undoubtedly have to have minimum of 3 servers to handle the current traffic, right? So on that case, in manual thing, the person has to look for there what exactly was the issues, and he need to immediately set up the new server, and he need to deploy to the end users or to the internet. So it do not have a self-healing capacity. If one server goes down, automatically the another new server should be launched without any intervention of human or any manual works. So it should heal up self itself. So that is not in there before the Kubernetes era. So to overcome all these issues, we have come up with the concept or the technology or the tool called Kubernetes or the Kubernetes. Okay. So what is Kubernetes? So Kubernetes automates operational stack or the task of container management that includes built-in commands for deploying the application, rolling out changes to your application, scaling your applications up and down to fit changing needs, and monitoring your application and more make easier to manage your application. So what they are telling is, so whatever the manual process we are used to do, right? So maintaining the infrastructure, maintaining the versioning and deploying the versions, and linking my application to load balancer, linking my application to do that is scaling up my infrastructure, and for auto healing or the self healing which was not there, everything is being managed by the Kubernetes itself without any interruption or intervention or interface of any of the humans or the manual process. Everything will be taken care by the Kubernetes itself once it's been rolled out. Okay, so even the Kubernetes is also known as K8s. So why it is called K8s means, so from K, sorry, it is S not R. So from K till S, we have between 8 characters. So they just normalized into K days. So we just understand how exactly these applications were deployed before Kubernetes and why do we require Kubernetes also. I've just given the introduction, right? So let us understand that the manual process of deployment of that is application. So without Kubernetes. So in physical server, what they used to have, you will be having one physical server running with your websites. For example, let us take some Flipkart or the Amazon IDs running on that physical server. So problem, what could be the problem that might arise in traffic increases? That is when the sales is gone, some seasons are their festive season. So they have offered for all the products, the people are rushing to buy at a time. So obviously the traffic will be more, and on those cases, if I have only one or two servers, it cannot handle that much of traffic. So everything has its own limitation, right? So to avoid all unnecessary crashes or downtime of servers, what we used to have, we used to add more servers, right? That is what we call it as auto scaling. So in manual thing, we do not have that concept. So the server gets overwhelmed and you must manually add the more servers to provide seamless service. That is, the server might behave downtime or it is overheated or it might get crashed. So to avoid those things, you must add manually. So when it comes to virtual machine, to solve these, we start using. So to solve these things, we use started using the VMs. Now you can run multiple VMs on a single physical server. So in single physical server itself, I can manage to run more web applications, right? In this also, I used to face a problem, that is while VM helps, they are heavy, take time to set up, and scaling is still manual. So what they are doing in VMs means, so if I want to scale up, auto scale up, or if I want to add more servers, even here also there is no concept of auto scaling, right? So in when I need to take up and I need to give instruct to hypervisor that I need more virtual machines as traffic rises uh, getting increased to manage all traffic, we required more servers, right? So for that we intend for VMs. So to set up all those VMs even manually, it takes up a lot time. So the time will going to kill. So we cannot provide on-time service to the end users. So obviously the latency will be more accessing the products, and some people can able to access the website, some are not because of due to high traffic. They used to keep trying. When the fraction of milliseconds, if they got chance, they would be getting into the access. So meanwhile, the team has to set up the new virtual machines. They have to configure. They need to deploy, and they need to integrate that new VMs to the load balancer for making available their server to the end users. So all these were taking too long to set up. So that cannot be happened in a fraction of seconds or the minute. So it takes quite longer time, right? So to overcome these things, they have come up with concept of containers, right? So here decided to use Docker containers to pack your web application, which makes it easier to deploy on multiple servers. So assume that in previous example, that is physical servers and VMs. So if somebody, let us consider some hotels, right? So what they used to do, they if based on the order or based on the demand what they used to get for the kitchen, on those cases they start preparing the, or they start cooking the food, right? So if someone's come and orders dosa, so the agent will go and tell the cook or the chef, so we have an order for this, and you just make it and you provide them. Like that, he will come right in the physical server and virtual machine. But when it comes to container, they keep everything ready. So if any customers comes and intended for some food, they just go, they serve it on their plate and they serve it to the customer. So exactly the container with Docker does the same thing. So what they used to do is they packed everything in one container, that is the what we call it as software virtualization. In virtual machine, they're going to virtualize the hardware components, but not the software thing. Software will be the independent one. So they have to install everything one by one, one by one, one by one. But when it comes to container, so once if I install for my Flipkart application means, if I want another servers to be deployed the same application, that is Flipkart, I will have order. I have readily one container which is having the Flipkart web application with all with required dependencies, with securities, everything. Just what I need to do, just I need to run new container. That's it. So this was what exactly being happened in the Docker containers, packaged your applications, which makes it easier to deploy on multiple servers. So when I have some container already ready with the same requirement, what I have to do, only I have to deploy it and I need to link to my load balancer is all my work. So comparatively, I have reduced too much of work as well as time, right? So comparative to virtual machine and physical server. So here also I used to face problem. What was the problem? What could be the problem? The problem is still we are using the manual process, right? You still have to manually start and stop and manage containers across the server. So here also some person needs to take care of all these work or the chores to be done and maintain to monitor in Docker containers, right? And just I mentioned while explaining all these things, that is auto scaling or sorry, manual scaling and the load balancing. So if more users visit your websites, you need to manually start more containers and update your load balancer to handle the extra traffic. So the problem is it consumes more time and might cause error too, right? So those were the issues while deploying the web application without the Kubernetes containers. Okay, so thereon, why we required Kubernetes. So we just understand what is Kubernetes. So we to automate all these process, what are the challenges we were facing in manual deployment, to automate all this process, we make use of the technology or the tool called as Kubernetes, right? So why do we require? So Kubernetes have auto healing capacity to in case of container loss without releasing the resource to others. So what they are telling is, so in case of container got crashed due to some electrical shorts or natural disasters or any of the heavy traffic, right? What the Kubernetes will going to do is, so the Kubernetes has its own architecture. We're going to see in future slides. Okay, so that pod keeps monitoring the containers and it checks for container health, container traffic, what exactly it's going on with container, whether the container is working fine, so does it require any treatments, like all those things. So if the controller found any errors or any malfunctions or any issues in the container, so automatically it instructs the Cube API server to do what exactly uh, the problem is, and it analyzes the problem and it throws the solution. So on that case, assume that your containers goes down due to some issues or the crash. So automatically what Kubernetes will API Kubernetes server will going to do means, so it will going to sorry so it will going, the controller keeps controlling of all these things through kubectl, right? So it will comment that and it will ask kube api server to deploy the another container, since the container which is already which was already running, having some issues and got that is crashed. So required another content to be created inside that pod. Like that, it will pass a command and it will take care of maintaining. So without any human intervention. So everything is automation, right? So that is Kubernetes master itself will take care of all the nodes or the container health, everything based on the requirement. It does its work. Okay, and also it is auto scaled for resources when required additionally. So you can see here that the pod 1 has 3 containers, the pod 2 has 2 containers, right? So based on requirements, so if a pod 2 microservice might require some additional proxy servers, so to go on like, so on that case, what exactly the controller will command and will set kube API server. So the scheduler will pass what exactly needs to be done. That is, it pass the command. So here it requires another container. Here I have a source code or the ready container. Just you need to deploy inside it, or like that it will pass a command. The API server will take care and it deploys another container over here, like that. Okay. And host OS initially checks for available memory to create a new container. If memory is not satisfied, it won't allow to create the container. So just assume that here I have a 10 GB and already the 9 GB is being filled of each 3 GB of containers, and I left with 1 GB. And here the same 10 GB I have in this pod, and I have left with another 4 GB. Assume that. So I want my pod 1 to have another container of 3 GB. So what API server will look? So it will look here for memory and all the requirements. So only if it is satisfied here, it will deploy. If not, it will throw back the notification saying that we are running out of memory in the pod 1. So kindly arrange for deployment, like that they will do, and they will initiate for auto scaling of the infrastructure here. Okay, so it won't carry from this here. So the pod 2 has a 4 GB that it won't carry from pod 2 to pod 1, and it won't create another container. So if pod 1 is lack of memory, it will instruct the certain API, let's saying that on that go the API will take care of auto scaling of the infrastructure or the resources. Thereafter the container will be deployed. Okay. So why do we use Kubernetes? So one of the benefits of Kubernetes is that it makes building and running complex applications much simpler. Here is a handful of many Kubernetes features. That is its standard service like it has its own DNS. So you do not have to buy or maintain separate DNS, load balancer, which are not there in before the Kubernetes, manual VMs and the Docker containers, right? And the most applications which are very essential one, that is DNS, load balancer, auto scaling features, right? So those are all this. So this is the architecture of Kubernetes. So whatever the command the developer used to pass to that Kubernetes master, that should be taken care by any of this. That is, we might use the interface called kubectl, or we might use APIs, or we will be having dashboard. That's true. To pass all whatever the commands we want to pass to that Kubernetes master, we make use of manifest file. We call it as. So in Ansible, we will be having the playbooks, but when it comes to Kubernetes, we will call it as manifest file. So what is manifest file? So you want something to be happened, right? For example, in your life, what we going to, we just make a points and we keep it and we keep seeing that. So these are the things will going to happen in future. Like that, the manifest file will going to define that the what pod, so that is a work node, what how many pods should contain, what is the name of the pod, how many containers should contain, In that content, which application should be running, and what are the resources it should run, that is how many CPU, how many RAM, how many memory should contain, what are the ports which are exposed to outside. So everything we going to write it here and send it to Kubernetes master etc drive. Okay, so from etc drive it will go to API server. From there it will send to scheduler. So what exactly the scheduler will do? So based on the commands passed from the controller to the API server, the scheduler will supply the requirements or the manifest file to perform the operations what are there in my manifest file. That is what I am saying to try is, so the API server act as agent here in the Kubernetes master. So the customer is entered, he just take his seat, right? So the agent or the whatever the waiter will come, and he takes the order and he went back to the kitchen. So in kitchen they prepare whatever the requirement they want, and again the agent will come and he'll going to supply like that. Okay, this is how exactly the Kubernetes architecture is going to work. So in manifest file, so what are the content we going to find, or what are the details we provide to create the containers or many things. Okay, so initially we will be having the API versions. So if I'm using Apache, or if I'm using any of the securities, that is STO or the service mesh, whatever the technology we will be using, we need to pull it from the Docker hubs. Okay, so what is the API? That is what's API group of objects and what is its version. That is if I am using some libraries, Java, the JDK, so what is the version exactly we are using, everything will be there. And the kind is something special that we want in Kubernetes. So we have three different kinds. That is, one is pod, another one is deployment, another one is service. So we're going to see those things. Okay, so what kind of container I am creating, sorry, what kind of pod I am creating is what I going to mention here. And the metadata is nothing but what I am creating, what are the details of my pod, everything will be the mapped here. And the specification, so the first three things, that is API version, kind, metadata, defines the pod, and the specification what they are doing defines the container details. Okay, so what should be the state of the object, which image to be used, any other configuration, everything will be mentioned here. So we're going to see all those things in one example file. Okay, so as I previously mentioned that, so the kind what I just mentioned, so what kind of Kubernetes pod I need to deploy, so is what I going to select from here. So if it is pod, means it's just a pod having the one container. If it is deployment, so I going to explain in future slides. And we have a kind of service deployment. So these are the major types of kind of Kubernetes manifest option. Okay, most commonly being used. So to view these master pods, so even we call it as this etcd controller, kube API server, scheduler, kubectl, kube proxy, these are all pods. We call it as pods, nothing but it's a kind of box. Inside that we have some application which are running and which is used for taking care of some work or the chore. Okay, so to view all those components or the cluster, we pass the command in your Unix or the Ubuntu. Kubectl is the agent get pods all, means I am calling all these pods to view whether they are actively running or not. Okay, to view the IP address of pods. So if I want, so each pod has its own IP address. So we all know that each and every components of the networking components which are connected to internet having its own IP, right? Same exactly here also. The TCD have its own controller, everything has its own IP address. To view those pods IP addresses, we just pass kubectl get pods -o void will throw back as IP addresses. And yet another one advantage V1 here is so assume that so the container or the pod which is assigned with some IP address that is 192.168.1.0, it got crashed unfortunately. So in Kubernetes we have a auto healing concept. So another pod or the container which get created, right? In that, do we think that the same IP address is assigned to that pod? Actually, no. So the new IP addresses will be assigned. Okay. So the previous pod ones 192.168.1.0, the newer version of the pod will get 192.168.1.2 IP address. That is what they are mentioned here. Once the pod is created and got assigned with the IP, one IP has been assigned for one pod, right? So same IP cannot be used even after the pod is deleted or crashed. So the same IP will not be provided there. That IP will be vanished. New IP will be provided to that pod. So here we have a kind, as I mentioned in manifest file. So we have a type of here is kind. So let me explain what exactly is going here. So just create a manifest file of the extension YAML or YML. YAML we call it as, right? Name can be for the convention purpose. We just mention if we are using the deployment some that microservice name followed by deployment, microservice name followed by service, load balancer, service mesh, everything. So based on the convention we make for best practice. So just name your file related to the content of your manifest file. Okay. So here I'm using the API version 1 and the kind is pod. So what does it says means? So there I have just mentioned the API version is 1 and I have instructed I'm passing the instruction to create a pod. Just I'm creating a pod without any container. First two lines and the metadata. So what are the information I'm providing is here we can see that, right, pod 1. So that is the name of that pod, but here I am giving Nginx for that pod. Okay. So thereafter I am passing this specific. So these 4 lines are the information of the pod, and what pod should contain is what I going to pass in the specification. So inside my pod I want to create a container. So what container I need to create? So here write container 1, container 2, container 3. So inside that pod I want to create one container. I name that container as Nginx. Okay. Then what operating system or the what version of software I should have in that container, I going to mention the name of that image here. So where will I get this image? You will be getting in the Docker Hub. So there are many available images which can be used, or if you have your own packaged container image, you can make use of it. And the ports. So in what port number this container or the pod is exposed or will be available to access. So that is what I going to mention that container port in the 80. So the Nginx version 1.14.2 is going to available in the port 80 prefixed by the container IP. Okay. So just now I have created some menu or I have ordered the products, right, or the food. So the agent needs to pass to the chef, right? So right now just here the agent come and he took the requirement only, but he has not passed anywhere. Okay, to reach the chef, what I going to do is I just pass the command to send these order items to chef to make that. Okay, so here I am passing. So kubectl apply -f. So name of your manifest file dot extension, that is YML, whatever the extension you are given here. It could be YAML or YML, any of these. Okay. So by passing this command, so the chef will going to create the pod along with the container inside, having the application or the server nginx of version. Okay. So this command will create the pod as mentioned in the file. So as instructed, this will going to prepare a pod with the container having the specification. Okay. So here only one container can be created. So if I want to create multiple containers, what I used to do, I used to make use of the kind or the type, I can say deployment. So in deployment, what we going to have, I can able to create multiple containers. In case of container crash, it going to auto heals itself, everything in this file. So in pod, we have only able to create a pod. That is single pod we can able to create. Pod does not support the auto healing of pod in case of pod crash. So due to some issues, if the pod got crashed, right, it won't auto heals itself. Again, I need to pass this command to create a new pod with the container. So when it comes to deployment, it's not required to run that command manually or again. So to create another pod in case of crash. So automatically it will going to create this one. So if the pod or the container got crashed, so automatically the another pod will be created with the same specification what we have provided here. But there is a slight change in the manifest file. We'll see those things. To overcome this issue, we make use of the kind deployment. So deployment helps us to create multiple pods and it has an auto healing feature in case of pod crash. Okay. So this is the manifest file and this is the name I have given. So pod-deployment.yaml. Okay. So here also I am using the API version 1, but here I have made a modification that initially we had pod, but here now we can able to see the deployment. So this is the type I am using of the type of Kubernetes feature, that is deployment, and the metadata. So what should be the name of my pod? Nginx deployment. So it's the convention or the best practice you can give what you are exactly doing. So it's not that predefined one. So the name can be given anything. And the labels. So the labels can be used for reference, future references. So if you want to create some containers inside that pod means, so look here. So initially I just created a pod with a container, right? So and now I want to have multiple containers inside this pod. So how will I know that I have to create my another container inside the pod one? So for that purpose, we make use of labels. That is labels, and the label name or the application should be, it can be anything. It's not to be predefined or anything. Okay. So here I have passed this Nginx and the specification for the pod I am mentioning here. Still I haven't been to container any details. Okay. So specification, in specification what I am telling is just create three pods, or sorry, three containers. So whatever the specification below I going to create, it should have three replicas. Okay. Thereafter the selector means where I should create. For that purpose I make use of label, that is match label. It's going to match the label that is referring to app nginx. So it sees that I should, what it exactly thinks that, so for this table I need to provide three dosas like that. Okay, just I am converting and explaining in simple manner. Okay, so the agent wants thinks that it will match that, so they belongs to the same table and they have ordered the same item of same food item like that. Okay, next is template, that is metadata. So whatever the configuration or the three dosas should have same configuration. That is, if one has ordered the butter dosa, the other two should also have the butter dosa like that. Okay, so that is what I'm mentioning here. That is a template metadata labels. It referencing to same pod itself or the same table. Okay, so what should be the food type, right here, that is I going to mention. So whatever the things I order in this specification should have the same configuration or the same food with the same ingredients just I mentioned priorly. And what should my primary order, that is what I am going to mention here, that is in specification containers. So the name of the food is Nginx, and what is the specialty or the chef who is going to prepare, that is the image name that you're going to get it from the Docker app. And it should be ready to be used or ready to be eat in what port, in the port number 8 like that. Okay, so likewise we have, so likewise in deployment, we see that we have an option of creating multiple containers. Along with that, we have a feature of auto healing capacity, right, in case of crash. So but we are still missing something, that is we created three different containers and we'll be having the three different IP addresses, right? So if I want to access all so three containers having the same Flipkart application having the different IP addresses, but the problem is I need to map all three IP addresses in my DNS, right? So it's quite complication. In case of crash, again I need to update my IP addresses in my DNS, right? So this was the issues I am facing in the deployment. So to overcome that, what we need to integrate to our deployment, we need to integrate load balancer. That is nothing but I can call it as a inbuilt DNS, right? So what it's going to benefit in integrating the load balance to my existing deployment itself. So in deployment, in by integrating the service or service deployment, what exactly it's going to happen means we will be having the three containers, right, in deployment. So the three will be having this, the three will be merged together, will produce us one IP addresses, and that is being accessed by the public. So we're going to see how to, so that is another over the top of deployment. We will going to write the another manifest, or inside that deployment only we can write, or we can create another manifest file. It's not an issue. So how you want, it's up to you. Okay, so the in this policy provides load balancer, thus avoids unnecessary crash of pods. So even though your crash, that is your got crash, even after integrating the load balancer, I cannot say that since it's a machines, anything can happen, right? So by integrating the load balancer, so all the traffic will be diverted to all the three containers. Okay, so based on the CPU utilization. Okay, that is why we have to monitor the CPU utilization to provide efficient service to the end user. So without any latency. So in delaying delivering the content of the web. Okay, so this policy built over the deployment policy, as I just mentioned, right? So directly I cannot implement the service. So initially I should, pre-requirement should be of deployment. So I need to have these contents over to this I going to integrate or embed the service one. Okay, to add the service policy already they should be running, that is the deployment should already be ready to add this service. So where it combines the pods into one cluster. So cluster, what is cluster means, assume that we have a multiple servers, right? so instead of saying the server room, we can call it as cluster. So having more than one server, we'll be calling in the technical world as a cluster. So while using this service policy, we do not use pod IP to get in. Instead, we use cluster IP. So I just mentioned, right? So instead of using the pod IP, we'll be having three containers, right? So on that case, we can just grab that IP followed by the port number so that I can able to get into that particular container. Okay. So when it comes to service model, so it's not required to have a pod. So all three containers merged together will have one single IP. That is, we call it as cluster IP. Okay. So we will be using the cluster IP. Okay, so this is how exactly it going to look actually, the service manifest file. Okay, so you can embed right next to this line, or we can have a separate file too. So API version again one, and the kind is service, and the metadata I am providing here is name. So here we are mapping the label of deployment to combine the pods. Okay, so in metadata, what exactly I am doing is, yeah, I'm using the engineers hyphen deployment, right? Here also I am provided the same name. Okay, so it will going to match that specification. Selector app nginx. That is, it's taking the information from here. Selector app nginx. Okay. So from thereafter, I'm defining the ports. So in what protocol it should go up, and in what port number it should be available to access. So my port number, sorry, I'll be using the TCP as a protocol, and my deployment container port number was 80. For that purpose, I'll be using 80, and the targeted port number. So in what port number you should be accessible for that, that is a 10.92.60, sorry, 86.204 colon 80. So targeted port, so what you are targeting is going to mention here to access that one. Okay, so if you want some other port number, you can mention it, and in that port number all the cluster will be available, or the Flipkart application will be available. So same command will be passed to apply the changes. Okay, so kubectl apply -f, the manifest file name followed by m. So to, so what we have just saw initially. So if you want to see our pods, what we used to pass kubectl hyphen. So to view our pods, what we used to do, kubectl get pods hyphen o, right? So if we have a different pods, so we will be passing this one, kubectl get pods hyphen o wide for the IP, hyphen a for all clusters, all available clusters. Okay, so what are the pods been, if you want to see what are the pods are created and running, you just pass this command, that is kubectl get pods hyphen a. And if you want to just get into that pod and want to access the content of that pod, means you just pass this command, that is to, you want to know that IP addresses, right? So on that case, you just pass kubectl get pod hyphen o wide, you will be getting the IP of that pod followed by the container port number. Okay, on that case you will be can able to gain access to that particular ports. Okay, so in case of service model, that is it going to merge all three containers or into one cluster, means on that case we won't be using that is kubectl get pod hyphen o wide to get the IP addresses. So the cluster will have a different command to get the IP addresses. Here we go that. So kubectl get svc is nothing but the service. If we type this, we will be getting this, that is cluster IP. Okay, so once we entered it, so we will be getting the cluster IP. From there, if you want to access that containers or the cluster, you need to pass this command, that is custom url -l, that is the length we can call, and we will be passing that we are using tcp. For that, http protocol we will be using, followed by the cluster ip. This is the cluster ip followed by the port number. So for which port or the which application I'm using, that will be this one. So even if the pods inside the container or the pod, here I have mentioned three, right, replicas. If one got down, so automatically the another will get generated, but it won't affect this IP address. The IP address will remain same. So this is the specialty of using the service policy. So this is the intermediate level of understanding of Kubernetes is. So we just come across what was the methodology and how they used to face challenges while deploying the application before Kubernetes, and we understood what is Kubernetes, why do we require Kubernetes, what are the benefits of having the Kubernetes tool, and what are the different features we want in the Kubernetes. Okay, so these are the things we have seen here. So this is all about the concept of the Kubernetes. So if you start learning about the manifest file, is more than enough. Just you should after watching this video, you just need to have the knowledge. So what has to be placed where. Okay, so I just mentioned the image, so where you need to copy the image name, even I have mentioned that from the Docker Hub. Okay, so rest will follow the same thing, only you need to modify is your image name and the port number. So what are the microservice, if you are using some microservices, what that microservice works on the port number, you need to update here. Okay, and the naming should be completely dependent on what exactly you are deploying. And here also a quite modification is required. Okay, so thank you all for watching this. Thank you. So here we can see the differences of virtual machine as well as the container. So how exactly the virtualization is happening here, let us see. So as I previously mentioned, so before Kubernetes, they were used to have physical medium. Thereafter, they come up with the virtualization, that is virtual machine. Again, to overcome the whatever the issues they are facing in virtual machines, they have come across this container concept. So the container concept is still being used, but with the supporting of Kubernetes. Okay, so in Kubernetes inside the pod, this is what exactly it's happening. Okay, so let us understand this visually. So this is my the infrastructure. I can say that that is my PC or the laptop or your system we can consider. So here I'm running Windows or Mac, or it might be Ubuntu, anything it might. Okay, so on top of that, I'll be installing the hypervisor. So it's a virtual machine, so that is a desktop application. To achieve virtualization, we required this one. For example, we have a VMware software, so where it will help us to virtualize the hardware components to provide the guest OS, I can say, as it shows here. Okay, so on top of that, that is inside the hypervisor application, so we can have multiple guest OS or multiple virtual machines irrespective of thing. So based, it's completely based on the infrastructure, so what is has been built. So for example, assume that we have 1 terabyte of infrastructure along with that 32 GB of RAM, and i5, sorry, i7 processor, it might. Okay, so here one virtual machine can have, so I'll be dividing that for 100 GB, assume that 100 GB, and for this I will be sharing the 4 GB of RAM, again the 100 GB, 4 GB of RAM, again the 100 GB and 4 GB of RAM. So here I have partitioned 3 hardware virtualization. So here I am not doing any software things. So if I want to do any software things, again I have to log into this guest OS one, and I need to install all the required dependency. So once it's done, again I need to go this and required to do perform all the tasks, and again the same thing. So this is the major drawback of using the virtual machine, that is especially the hardware virtualization. Fine. So when it comes to containerization or the Docker, or yeah, Docker containerization means, so we have an infrastructure same as the virtual machine has, but on top of that, we do have operating systems about to that container engine. That is, we are using Docker engine. Okay. So on top of that, we'll be having the many containers. Fine. So in container, so assume that in one container, so I wanted to run login things. So whatever the dependencies we require, the application libraries and the source code, everything. So will be kept here. Okay, in app one of bins of lib. Okay, so I'll be storing in this one. So here, uh, just observe that here we are using the hypervisor to make virtualization, but here we are using the container engine. So here we are not doing any hardware virtualization. So whatever the software I want here, operating system, on top of that I'll be using the container engine to just embed my all dependencies into one container. So in this case, if I require to have multiple container of same Flipkart application means, so whatever the container I have in app 1, I can reuse of same container for app 2 and app 3 also, so if required. So as I previously mentioned that in case of increase in accessing of data or the content during the sales. Okay. So auto scaling concept, so completely it works on this one. So here we are just virtualizing the software but not the hardware. So hardware completely taken care by the operating system itself. So if it is wants to use only the 100 GB and 4 GB of RAM, so rest will be allocated to rest of the containers. So it will be managed by the container engine. Okay. So the virtualizations, the software virtualization completely will be taken care by the Kubernetes master, and we will be pushing the instruction through any of this medium to master, and master will going to, that is a API server will going to perform. So whatever the manifest file has, and it will deploy in the things. So as we can see here, we are using the multiple software inside the pod. That is, each container might have different application or might have same application. So we are just virtualizing the software but not the hardware things. So this is the exact differentiation I can define. So this is all about the Kubernetes technology. Thank you.